A new beginning, a brand new start. A new beginning, a brand new start. Take up knitting and learn to dance. Take up knitting and learn to dance. Live your life as if there is no tomorrow. Live your life as if there is no tomorrow. Make your peace and feel no sorrow. Make your peace and feel no sorrow. Leave your troubles far behind. Leave your troubles far behind. Look forward and clear your mind. Look forward and clear your mind. So hello my shimmering stars. Today I, Shaurya Grover, welcome you all to this amazing platform of PW English. Today we shall be starting our inorganic chemistry. Yes, I am going to teach you inorganic chemistry and we are going to start with our chapter P block elements. Under which batch? Excellence batch. So the name of the batch is excellence. That means with great determination, hard work, consistency, we are going to excel in our field. If you are going to follow the steps which I shall be saying you. So the very first initial step that you have to keep in your mind while listening to the lectures, that is you have to pay huge attention. When I shall be saying you that students kindly understand this concept, pay your attention in understanding the concept rather than writing it down, then you have to follow it. Because I will be providing you enough time to write the things that I shall be writing on the board over here. So when I'm explaining you, your main focus, your important key point should be that you have to listen to the topic first. When I will be saying you that kindly write it down, you have the enough time, you can write it over there, then you have to write it down. This was your first step, that you have to pay huge attention. The second step, I shall be taking the NCRT important key points in the lectures, in the sessions you shall be seeing that. I have taken some of the topics, NCRT lines. First of all, I shall be explaining you the topic, then we will be reading it from the NCRT. So your second step, when I am saying that you have to read this topic from the NCRT, after understanding the concept, then you have to do that as your homework. It is really very essential. The major topics, NCRT reading topics I will be covering over here, and I will be giving you minutes also to read on your own, so that you can, practice your mind over there, that how the concept is applied over here. The third step, the third most important point is to solve your practice sheet or your DPPs, whatsoever you say it, okay? I shall be providing you the questions with respect to the lecture that we have been understanding, okay? So you have to solve that questions. Okay, this is your third most important key point. And the fourth one is there shall be some questions which I will be taking as a homework over here in the lecture itself. So practice sheet or DPP questions, the questions which you are unable to solve, the third key point, you can just write in the comment section that ma'am, we are not able to solve this question from this practice sheet or DPP. I will be taking up in the lecture. Okay, when I'm talking about the fourth major key point, that is the homework part, over that I want you all to write on that day whenever you are listening to the lecture. For example, you have just covered the session, you have just finished the lecture over here. When you are revising it down, you have to solve the questions and you have to write the homework question answer itself in the comment section with your name. Why I'm saying you to do this? Because what happens, students, is there are some students which will be able to solve every question. I'm not saying majority of the people. I'm saying some of the students will be able to solve question in the very first attempt. The second most priority of the students comes around who know the concept but are unable to apply in the questions. So half of the questions they shall be solving and half will be the one they may not solve it out. Okay. And the third kind of categories which are not able to solve any of the question. So what I want you all to do is to just write in the comment section whatsoever your answer is. So that if your answer is correct, you shall be feeling proud on yourself that yes, I have commented this answer of the homework question which was given in the lecture and it is correct. So that will be a proud moment for you. And when your answer is wrong and you have commented wrong answer in the comment section, so it will be a lesson for you that in the next lecture, when ma'am will be giving us next questions, I will be the one who will be writing the correct answer. So by this way, it will become a habit for you to solve questions. See, I don't know you are solving practice questions or not. Are you practicing or not? I have no particular idea of it. But by looking up to the comments that I shall be giving the homework questions over here, when I'll be seeing your comments, I will be understanding that yes, this student is working hard. This student is solving questions. So this will be a check on you that you are doing questions or not. So basically, you have to solve a practice sheet also. The fourth major key point was the homework questions, which I will be giving you in the lecture itself. That. And the fifth, the major important point that you need to remember is revision. Revision is really very important whenever I talk about inorganic chemistry. Why? Because see, you understand the topic on a particular day. After one day, you will be remembering the topic. I would say within a week, you are remembering the topic, but with the lap of time, with the passage of time, what happens? With the passage of time, you are covering all the subjects, right? So with passage of time, when you are not revising a particular topic, I'm considering this with all subjects, okay? I'm referring it to all subjects. Whenever you are being provided to a particular lecture and you are not revising it out, my dear students, then with the passage of time, the topic basically vanishes out. So your major task is to revise it properly. You have to just give half an hour daily to your revision section. Okay, whatsoever you are covering in today's lecture, before going to sleep, you have to revise it. Just make it a habit. So I have told you 5 major points that you need to remember, you need to follow, and I assure you that inorganic chemistry will be easy for you and you shall be solving all the questions which will come in your examination, right? So we shall start our session with a beautiful smile. As I have told you that today we will be starting with our lecture number first based on the chapter P block elements, okay? Now students, whenever I talk about P block elements, see, you will be seeing the P block elements topic in your class 11th standard also. In class 11th, you were having 13th group and the 14th group. But as per the class 12 syllabus, you have group 15, group 16, group 17 and group 18. That means from group 15 to 18, we shall be covering in the 12th standard. So today, in today's lecture, our main focus will be on group number 15. Now, what is group number 15? It is nitrogen family. So, we shall be focusing on group number 15. So, let us write that what are the topics we are going to cover today. Topics to be covered. Our initial topic will be introduction. Our initial topic will be introduction to P block elements. Introduction to P block elements. Then we are going to start with our group number 15 elements. That is basically nitrogen family. That is basically nitrogen family. Then we shall be covering the physical properties. Then we shall be covering the physical properties of group number 15. And after that, students, we shall be looking up to the chemical properties. We shall be looking up to the chemical properties of group number 15. So this is going to be the topics that we will be covering in today's lecture. Is it clear to you? So we shall start with our very first segment, that is introduction to P block elements. So whenever I am talking about the introduction to P block elements, why are the elements that I shall be telling you which are the elements that are being placed in the P block family? My question is, why are the elements we refer to as a P block element? Why the particular elements are referred to as a P block elements? What is the basic reason that a name P block is assigned to certain elements? My first question is to you all. See, whenever I am talking about P block elements, or I would say about any elements in which the last electron, I would say the last electron enters in the P subshell, that elements lies in the categories of the P block elements. Are you getting my point? What I am saying, yes, there is an exception. Exception is there and I shall tell you why the exception is there. But first of all, understand why elements are called P block elements. Because the elements in which the last electrons enters in the P subshell, they shall be referred to as P block elements. For example, nitrogen. For example, phosphorus. For example, fluorine. Are you getting my point? I will be explaining you how. First of all, write the definition. What are p block elements? What are p block elements? Elements in which electrons, in which last electron enters in p subshell, is referred as p block element. Let us take certain examples in order to understand the definition. But before moving to the certain examples, this definition is yet incomplete. Why it is yet incomplete? Because as I've told you, there is an exception. The exception is helium. So here you can write except helium. Why except helium? Now, helium is a p block element. No doubt it is a p block element. But over here, I will tell you one thing, that it comes under the category of group number 18. But over here, the last electron enters in S subshell, not in P subshell. Other than helium, all the elements that lie in the group number in the p block elements, their last electron will enter in the p subshell. Are you getting my point? Now, let me tell you the basic things with the help of examples. For example, let us understand this initial definition, that elements in which last electrons enter into the p subshell are p block elements. But yes, helium is an exception in which last electron enters in the s subshell. Okay, so example that I am talking about here is, first of all, we shall be taking of nitrogen. So what is the atomic number of nitrogen? See, whenever we are writing atomic number, we write it at the base. So nitrogen atomic number is written at the base. Whenever you will be writing its mass number, okay, so that you will be writing on the top over here. Is it clear? So I'm writing atomic number over here, it's 7. Now what will be the electronic configuration of nitrogen? It is 1s2, 2s2, 2p3. How I've written, I guess this is clear to you how I've written. Still, I will tell you, we have to fill the 7 electrons. Initially, the electrons will enter into the 1s shell. So, S holds maximum of 2 electrons. P will hold maximum of 6 electrons. D will hold maximum of 10 electrons. Is it clear? So, first of all, in 1s, I told you S holds maximum of 2 electrons. From 7, 2 electrons are given to it. How many electrons are still left? 5 are left. Okay. Now, it will enter into the second subshell. So, 2s, how many? Again, in S, 2 will come. So, 2 plus 2 is 4. 4 electrons are filled. How many are left? 3 are left. So, now it will move up to which? In second only, it will, in second shell only, it will move up to the P subshell. That means 2p3, because 3 electrons were left. So, this is the electronic configuration. Now, is it a P block element? How we will identify? The last electrons enters in which subshell? In P subshell. So, this is an example of what? This is an example of P block element. Now, let us take one more example in order to understand. Fluorine. Fluorine atomic number is 9. So, again write its configuration. Initially, it is 1s2. 2 electrons are filled. How many are left? 7 are left. So, again 2s2. How many? 4 are done. 5 are left. So, it will be what? 2p5. Is it clear to you? I told you P subshell will hold maximum of 6 electrons. So 5 electrons are filled over here. So now the last electron over here enters in which subshell? The last electron over here enters in P subshell. So this is also an example of what? P block element. Now again, if I have to write of helium, if anybody has a problem over here, you can also mention of this. Helium has an atomic number of 2. Helium has an atomic number of 2. So if you want to write its electronic configuration, it shall be 1s2. It shall be 1s2. That's it. Is it clear to you? So here the last electron is entering in which subshell? S subshell, not in the P one. So it is an exception over here of the P block elements. Is it clear? It is an exception in the P block elements. Other than helium, everyone, each and every one of the element holds this category that their last electron will enter in the P subshell. So now one more thing. How many p orbitals are present? So basically there are 3 p orbitals over here like this. And how many maximum of electrons are present? Now what are the p orbitals? P orbitals are px, py and pz. I guess this is clear to you. And how many maximum electrons this basically orbitals can hold? You should know that one orbital will hold a maximum of 2 electrons. So 1, 2, 3, 4, 5 and 6. So that means the 6 electrons are the maximum electrons that are present in the p orbital. Is it clear to you? Or that are present in the p subshell, I would say. Is it clear to you? So 6 electrons are the maximum electrons that are present in the p subshell. As I've told you, in S there are maximum of 2, in p it is 6, in d it is 10, in F it is 14. So in p, if I talk about p subshell, how many electrons are maximum? 6, because each individual orbital contains 2 electrons, 2 over here, 2 over here, 2 over here, and it shows 6 electrons. I hope so the orientation of electron is clear to you. I have written one electron like this and another one like this. Why? Because they have different spins over here. The orientation is different. One has an anti-clockwise spin, another has a clockwise spin. That's why. Is it clear to you? I hope so this basic understanding of the p block elements is clear to you right now. So if I ask you about p block elements, from which group to which group are the p block elements? My question is now this. Which group holds p block elements? So from p block elements are p block elements lies between group number 13 to group number 18. That means all of these groups hold the p block elements in itself. Is it clear to you? Now I will be showing you the periodic table, but before moving to that, I want you all to write this basic definition of p block elements over here so that we can move on further. So I hope so you have first understood the concept. Now I've given you a minute to write it down. So you can pause the video and write it down. Okay, kindly pause the video and write it down first of all. Shall we proceed? Great, students. Now students, as here you can see, this is the periodic table over here that is being provided to you, and these elements are which one? The p block elements. In the periodic table, if you'll see, the p block elements lies on the right hand side. The p block elements lies on the right hand side. We have taken this and enhanced it over here. So these are p block elements. If I talk about this is boron family, and this is group number 13th. Okay, so then comes your carbon family. This is your group number 14th. Then comes your nitrogen family, that is group number 15th. Then comes your oxygen family, that is your group number 16th. Then comes which family? Fluorine family, that is group number 17th. Or I would say the halogen family, that is group number 17th. And the last one that I shall talk about is group number 18. Okay? Neon, argon, krypton. Here one more thing. Here helium is absent. You have to write helium also. Helium is also here. Okay? Above neon. Is it clear? Okay. So these all are, if you want to mention over here. So basically these all are your p block elements. These all are your p block elements. And today we shall be covering the group number 15 elements. That means we shall be studying about this one. We shall be studying the characteristics with respect to this group. Is it clear to you? I guess this is now clear to you. This is the periodic table of p block elements. Right, my dear students. Now before moving on to the next concept, I want you all to write the electronic configuration. Just as we did over here, we have written the electronic configuration with respect to nitrogen and fluorine. We shall be writing the electronic configuration as per the particular groups over here. Okay, so let us write it down first of all. If I talk about group number 13, see, first let me tell you what is the general electronic configuration of p block elements other than helium. So general electronic configuration, let us write it over here. General electronic configuration is basically, except helium, I am just mentioning over here again, except helium for p block elements is NS2NP126. This is the general electronic configuration, my dear students. Now this configuration is for valence shell electronic configuration. Also you can mention over here, this I am writing for valence shell or the outermost shell electronic configuration. Is it clear to you? What is the valence shell electronic configuration or general electronic configuration? It is NS2NP126. I will be explaining you in detail how, but for all of these groups we will be writing. Now, shall we write? Okay. So, for group number 13th over here, let us write for group number 13th. For group number 13th, it is NS2NP1. What is the general electronic configuration for the boron family? It is NS2NP1. It is group number 13th. Is it clear? Now for group number 14th, what is the general electronic configuration for group number 14th? It is NS2NP2. What is the general electronic configuration for group number 14th? NS2NP2. Okay. What is the general electronic configuration for group number 15th? It is NS2NP3. NS2NP3. Then we have the group number 16th over here. What will be the general electronic configuration for them? It will be NS2NP4. What will be the electronic configuration for group number 17th? It will be NS2NP5. And last but not the least, the group number 18th general electronic configuration shall be NS2NP6. So over here you can see that the general electronic configuration or the valence shell electronic configuration is lying between NS2 NP126. Over here NS2 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 is filled, but NP is 1 2 3 4 5 6. So generally we can say it lies between NS2 and NP126. Is it clear to you? Is it clear to you? Is it clear to you? Now, one more important key point that we will be understanding in depth in the coming session, in the coming few minutes. But before moving, I want to give you a brief intro over here. That when I talk about the initial elements, boron, carbon, nitrogen, oxygen, fluorine, not neon I'm talking about boron, carbon, nitrogen, oxygen, fluorine. These elements basically show anomalous behavior. They show anomalous behavior, a different kind of behavior with respect to the other elements of their groups. When I'm talking about a boron in boron family, it shows a different kind of behavior with respect to the other members of the same group. It will show a carbon will show a different kind of behavior with respect to the other members of the group. Similarly, nitrogen will show a different kind of behavior with the other members of the group. And so is oxygen, and so is fluorine. Why they show anomalous behavior? In brief, I'm telling you in detail, we shall be doing this, okay? So the major reason is that these initial elements which are of group 13, 14, 15, 16 and 17, they don't have any d orbital. So there is an absence of d orbital over here. The initial point is that why they show anomalous behavior or the different behavior is due to the absence of d orbital over there. Moreover, due to the small size. Moreover, due to the small size of these elements. These elements have small size and there is no d orbital present over here. So they show a different kind of behavior with respect to the other members over there. Is it clear to you? Is it clear to you? Okay, now over here, before moving forward, one question that may arise in your mind is what is n over here? N basically over here is the period number, or you can say the shell number. So over here n is the period number or the shell number, right? Now, ma'am, you have told of all the elements, but you have not told of helium. Again, I have written of helium in the previous slide. It is 1s2. The configuration is 1s2 for helium. Is it clear to you? Is it clear to you? Do put a star mark over here for NS2 NP126. Can we proceed to the next part over here? I hope so. You all have written this right now. Okay, so now we shall be focusing on the group of 15 elements over here. That is our today's segment. So this was the introduction to P block elements. Is it clear? As again I shall be saying, this group 13th and 14th is in your 11th standard, but from group number 15, 16, 17th and 18th is in your 12th standard, in your 12th class syllabus. So we shall start with the group number We shall start with our group number 15 elements. Let us start with group number 15 elements. Now, what are the group number 15 elements? Just you have seen right now. So, we shall write one by one. It is, N is what? N is nitrogen. N is what? N is nitrogen. The initial element is nitrogen. Then comes what? Then comes phosphorus. You can write it with me. This you can write it with me. Nitrogen, then comes phosphorus, then comes arsenic. As you can just also look over here, but I am going to tell you more key points, so write it individually. When I am saying write it, it shall be a practice for you. I am making you practice, so you have to write. As is arsenic. Arsenic. Now it is a kind of a different thing. Here you shall be representing it by SB, but the name is antimony. Okay, what is the reason that, see, here nitrogen is, here the name is nitrogen of the element and it is represented by capital N, the first initial letter. Then phosphorus, the first initial letter is P, so represented by P. Arsenic is represented by AS, but antimony is represented by SB. Why, ma'am? Why it is happening over here? So the reason behind is that the element SB, basically antimony's Latin word, antimony in Latin is referred to as stibium. Okay, so it is basically stibium. So over here, this stibium is a Latin word. So from here, this SB has been written. This is denoted by the SB symbol from this Latin word over here. Is it clear to you? Now, it is nitrogen, phosphorus, arsenic, antimony. Now comes your next one, that is bismuth. That is what? Bismuth. So it is represented by Bi. It is represented by Bi. Bismuth. Bismuth. And there is one more, students, if you want to write, you can write, but it is a radioactive element, so we shall be not covering it in detail. That is MC over here, that you can see over here. This is MC. This is MC. This is MC, that is mosconium. Okay. So if you want to write, you can write. It is radioactive in nature. Basically, its T half-life, that is very short. So, very much detail is not being provided of this particular element and we shall not be covering it in detail. We shall be understanding from nitrogen till bismuth. Is it clear to you? Now, first of all, let us write the atomic numbers for all of them. How we will write the atomic numbers for all of them? Initial one atomic number you should remember. For example, if I am talking about nitrogen, I know the atomic number of nitrogen 7, because I guess each and every one of student has learned the atomic numbers till element 30. I guess it is up to me that I think that you have learned. Okay, but if not, there is no problem. At least you have to learn till 20, because after that we shall be using the short trick and we can do so. Okay, so nitrogen has an atomic number of 7. Now what we are going to apply over here, we are going to use this rule 2, 8, 8, 18, 18, 32. So initially what you're going to do, you will be starting from here. Okay, as nitrogen comes under the second period, let me tell you, nitrogen comes under the second period. Okay, so you have to start from this 8, 18, 18, 32, 32 onwards. So if its atomic number is 7, now your next step is to add how much? 8. You will be add how much? 8. When you are going to add 8 and 7, it becomes 15. So the atomic number for phosphorus becomes 15. Now the next step, after adding 8, you will be adding what? 18. Now you will be adding what? You will be adding 18 over here. So what will be the atomic number when you are going to add 18 and 15? It becomes 33. So arsenic atomic number comes out to be 33. Now next, what you are going to add over here? You are going to add 18 again. You are going to add 18 again. What will be the atomic number? It is 51. So the antimony atomic number comes out to be 51. We represent it, we write atomic number at the base. Okay, is it clear to you? I am telling you very basic key points. If you are new to inorganic chemistry, if you are unable to solve chemistry, I feel that it will be easy for you to understand if you are listening to the very small key points. Great. Now after 18, 18, we will be adding 32 over here in order to calculate the atomic number for bismuth. So what will be the atomic number for bismuth when I am adding 32 and 51? It becomes 83. It becomes what? It becomes 83. Now next step is, again I am going to add what? 32. Again I am going to add what? 32. So what will be the atomic number over here when I add this? It becomes 115. It becomes 115. Is it clear to you? So what are the atomic numbers? Let us represent this with the purple color. This 7, 15, 33, 51, 83 and 115 are the atomic numbers of these particular elements. I guess this is now clear to you. Okay. Now again, what is the general electronic configuration for group number 15? For group number 15, general configuration was NS2NP3. General electronic configuration for this group is NS2NP3. What? NS2NP3. So we shall be writing the electronic configurations. The outermost electronic configuration. The valence shell. What I have written over here. Just remember this thing. I told you the valence shell electronic configuration. The outermost. What is valence shell? The outermost shell. Okay. I will explain you what I am saying, valence shell or outermost shell. If it is not clear to, I will explain you right now. But before that, let us write with respect to this. As I've told you, nitrogen comes under the second period. So this will be, phosphorus will be from third period. Arsenic will be from fourth period. Antimony will be from fifth period and bismuth will be from sixth period, right? Second period, that means over here, if you remember when I was explaining you this, I told you N over here refers to as number of shell or period. N over here refers to as number of shell or period. That means over here, if it lies in second period, that means N over here is 2, N over here is 3, N over here is 4, N over here is 5, N over here is 6. Am I right? Am I right? Am I right? Right. So now, if I have to put the value of N over here and we can write the electronic configuration, yes. If I put N value as 2, what will be electronic configuration for this? It will be 2s2, 2p3. Okay. If I put N value as 3 for phosphorus, what it will be? 3s2, 3p3. Okay. If I have to use for arsenic, it will be 4s2, 4p3. If I have to write for this, it will be 5s2, 5p3. If I have to write for this, it will be 6s2, 6p3. Is it clear to you? Is it clear to you? So by this way, you can write the electronic configuration. You will say, ma'am, only this much electronic configuration. Again, I'm saying this is valence shell electronic configuration. Now I will explain you what I meant to be valence shell. Okay, we will write the electronic configuration for phosphorus now. Okay, let us write for phosphorus over here. You will understand my key point. Phosphorus atomic number is 15. So what will be electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p3. Just see. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 3 is 15. I have told you right now over here, these are the electronic configuration of the valence shell. That means the outermost shell. Outermost shell is third shell. Outermost shell is third shell. Outermost shell over here is fourth. Outermost here is 5. Outermost over here is 6. By this way. These were the shell number or the period number. That means this is the outermost shell. This is your first shell. The second shell. The third shell. So this is your valence shell or the outermost shell, I would say. This is your outermost shell. So this configuration only, I have told you a shortcut. I have told you a shortcut for this. What is that? NS2NP126. For 15 group element, it is NS2NP3. For 15 group, it is NS2NP3. So this is what we have written over here. This is what we have written over here. Are you getting my point? Okay. Now we shall write the nature over here also. This I'll write over here. Okay. This I'm writing over here. 2, 8, 8, 18, 18, 32. We have written from here, right? Now we will be writing over here its nature. This was the configuration. Outermost configuration, the valence shell configuration. And here we are going to write its nature. Now what is its nature? Nature refers to as that how they exist basically. Nitrogen exists in diatomic form, that is N2, and it is gaseous in nature. It exists as N2 and it is gaseous in nature. If I talk about phosphorus, it exists as P4. Okay, and it is solid in nature. While if I talk about the other ones, they all are solid in nature. Arsenic, antimony, bismuth, they all are solid in nature. Is it clear to you? Other than this, if I talk about the metallic and the non-metallic character over here. Okay, other than this, if I talk about the metallic and the non-metallic character, let me tell you, nitrogen and phosphorus both are non-metals. It is non-metal. It is also non-metal. Nitrogen and phosphorus both are non-metals. But if I talk about arsenic, if I talk about, antimony, they are metalloids. They are metalloids. Now, what are metalloids? Metalloids are the one which hold the characteristics of both metals and the non-metals one. So basically, this is also a metalloid. This is also a metalloid. Now comes your bismuth. Bismuth basically is your metal. Is your metal. Bismuth is a metal. Great. But it is a poor metal. Okay. And also when I talk about the last one, MC, it is also a metal. It is radioactive. We shall not study in detail, but yet it is also metallic. Okay, so this is these two initial ones, the nitrogen and the phosphorus, are non-metals. Then comes the metalloid one and comes the metal one. I am giving you 1 minute so that you can write it down. Kindly write it down, my dear students, so that we can proceed further now. Shall we proceed further? So this was all about the elements in the group number 15 that we will be writing again and again. And one more thing, I will be not writing the complete name again and again. I will be using the symbols over here. So I've given you a brief introduction about it. Now let us see the NCRT line. These are your NCRT line of occurrence. We will be seeing that where do they occur. So we have to cover this from NCRT only. So I have taken the NCRT lines. You can even open up your NCRT. You can even open up your NCRT over here if you want to understand this. Or you can just kindly read it from here also. There is no problem. Let us see. Okay, so now listen to me very carefully. They say that this, I guess you are aware from your lower standard, from your lower classes also, that nitrogen comprises 78% of the volume of the atmosphere. We all are aware of this thing. But the thing which we are not aware is that in the earth crust, it exists as a ore. In two kinds of ore it exists. What are the two kinds of ores in which it exists? It occurs at sodium nitrate, that is NaNO3. The very first initial is it occurs as sodium nitrate. Let me see if this color is visible to you all. Okay, I will be using a yellow shade, light yellow. Okay. Okay. So I guess now it is clear to you. Yes. So basically, first ore is that it occurs in the earth's crust as sodium nitrate, that is NaNO2, which is known as child saltpetre and child saltpetre. And this question is, I guess, either in your today's session or in your practice session. So this question you shall be looking over there also. And it also exists as one more ore. It also exists as one more ore, that is potassium nitrate, which is known as Indian saltpetre. Okay. Now, it is found in the form of proteins in the plants. This is the theoretical section that you have to read, okay? So, these were the important key points that I have mentioned over here. Rather than this, it is found in the form of proteins in the plants and the animals. Phosphorus occur in the minerals. Now, it was initially about nitrogen. Now, we are reading from here about whom? About phosphorus. From here, phosphorus. Phosphorus occurs in the minerals of the apatite family, such as they have given you the certain examples over here, okay? And there are some examples that here phosphorus is present, as you can see here. Phosphorus is present, as you can see. Okay, now next is, which are the main components of phosphate rocks? Phosphorus is an essential constituent of animal and plant matter as well. It is present in bones as well as, here well will come, as well as in the living cells, okay? There is no need to learn it, just you have to read it out. Again, I'm saying occurrence portion is the one in which these two were key points. Other than this, you just have to read it out. Next is arsenic, antimony and bismuth are found mainly as the sulfide minerals, and moscovium is a synthetic radioactive element which I've already told you, whose symbol is Mc. Moscovium, okay, whose atomic number is 115, which we have already done. Atomic mass they have given you, no need to learn it out. But yes, again the electronic configuration, what you need to do is know the outermost electronic configuration, that is 7s2 7p3. See, it was 6s2 6p3, this was 7s2 7p3. So outermost, just you need to remember. Outermost is the one that you need to remember. Due to the very short half-life and the availability in the little amount, its chemistry is yet to be established. So there is no more research yet. When it will come, we shall be understanding about it. Is it clear to you? So this was all about occurrence. Now we are going to start with the physical properties with respect to the nitrogen family. Now we have done the general introduction with respect to the group number 15 elements. Now we are starting with the physical properties. Students, when I am talking about the physical properties, I will be talking about the melting point. I will be talking about the boiling point. I will be talking about its atomic radius. I will be talking about its electronegativity, ionization energy. All of these concepts will be covered in the topic physical properties. Now, the very first initial physical property that you need to remember is the atomic radius, which is the most important one. Atomic radius. This is very easy also. And don't get confused that we have not done in 11th class. We will be able to understand in 12th or not? You will be able to understand in 12th class. The concepts that are used from your 11th standard, I will be explaining it to you again. So there is no issue if you have not done in 11th class. Great. Now, we shall be writing all the elements. Nitrogen, phosphorus. Now write it down. Arsenic, antimony, bismuth, right? Write it down. These are your elements, right? Now, what is the effect of the atomic radius on the group number 15 elements? See, when you move from top to bottom, that means when you are moving down the group referred to as you are moving from top to bottom. What happens? You know that here the period number is 2. That means shell number is 2. Here the shell number is 3. Here the shell number is 4. Here the shell number is 5. Here the shell number is 6. What do you refer to as shell? What do you refer to as shell? For example, this is your nucleus. This is the first shell, the second shell, the third shell, the fourth shell. Are you getting my point? So what happens when you are coming down the group, the number of shells are being increased. The number of shells are being increased. So what will be the impact on atomic radius? What is atomic radius? The atomic radius is the distance from the nucleus to the outermost shell. That is atomic radius. So when you are going down the group, you are seeing the number of shells are being increased. The number of shells are being increased. That means atomic radius. That means the distance from the centermost to the outermost region will also increase. So we can say that as we move down the group, what will happen? Number of shells increases. Now this is a symbol that I will be using again and again for increase. Okay, I am mentioning over here. This is a symbol which I will be using for increase. And this is a symbol which I shall be using for decrease. So don't get confused in both of these. So I am saying that when you are moving from top to bottom, that means from the shell number 2 to shell number 6, then number of shells are being increased, due to which we can say that the atomic radius will also increase. The atomic radius will also increase. I guess this is clear to you, right? Kindly write it down so that we can move on to our next concept and we can read it from NCRT as well. Kindly write it down. See, this was the very most simple, the property that we need to know, right? So over here, when you are going to read it from your NCRT, what they have told you with respect to atomic radius, covalent and ionic. Now these are the types of atomic radius. Okay, in a particular state, radii increases in size down the group. So they are saying the covalent and the ionic radii, when we talk about the atomic radii, basically they will increase down the group as you move. This is considerable increase in covalent radius from nitrogen to phosphorus. However, from arsenic to bismuth, only a small increase in the covalent radius is observed. Now they're saying increases there, no doubt, but the covalent radius increases more with respect to when you're moving from nitrogen to phosphorus, but after that there is a slight increase. But there is no need to go in depth. You just need to understand that when you are moving from the top to bottom in the group number 15, atomic radius will increase because the number of shells are being increased. Is it clear? Okay. This is due to the presence of completely filled d or f orbitals in the heavier members. Now this is explaining why arsenic to bismuth, the atomic radius is increasing, but very less it is increasing. Why? Because there is a presence of d or the f orbitals in them. So this was all about the atomic radius. These are the lines from your NCRT students which I have taken over here. This was your very first key point that you need to understand. Other than this, what they can ask you? The second most physical property is about density. The second most is about density. So again I will write nitrogen, phosphorus, arsenic, antimony, bismuth. I want you all to write with me. So as you move down the group, what happens? You know mass is increasing. If mass is increasing, what is density? Density is equals to mass by volume. If mass is increasing, that means density is also increasing. It is as simple as it is. So density is also increasing. Down the group when you go, density will also increase. Is it clear to you? I guess this is now clear to you. Now if I talk about the next physical property over here, the next physical property shall be, the third one shall be about the melting point and the boiling point. First of all, let us talk about the boiling point. The third physical property that I am talking about over here is boiling point. Now, when I'm talking about boiling point? Boiling point always depends upon the molecular mass. Do remember this thing. Boiling point always directly depends upon the molecular mass. More the mass, more will be the boiling point. Or we can say boiling point is directly dependent upon the van der Waals forces. It is directly dependent upon the van der Waals forces. There is a trend of boiling point that you need to remember. As I've told you, boiling point depends upon the molecular mass. So when you go down the group, atomic radius increases, that means atomic mass is increasing. Number of shells is being increased. When you move down the group, atomic mass is also being increased. So when you move down the group, if atomic mass is increased, that means boiling point will also increase. So if I write nitrogen, phosphorus, arsenic, antimony and bismuth, our order should be like this. That means bismuth has more mass, then it will have more boiling point. Our order should be like this. But the trend changes over here. Yes, it increases down the group, but at a certain point, bismuth has less boiling point than our antimony. Bismuth has less boiling point than antimony. This is the order that you need to remember over here. From nitrogen, it is being increased. It is being increased because the atomic mass increases, so boiling point will increase. But there is a slight change over here. Bismuth will have less than whom? It will have less than antimony. Is it clear to you? Is it clear to you? The answer for this question is due to inert pair effect. I will be explaining you in the upcoming slide what is inert pair effect, but still, first of all, write it down. Write it down. Okay, now, shall we write to the next one? I guess you have written the boiling point. Now we will be writing the melting point key concept. Okay, let us write the next one, that is the melting point. The fourth one is melting point. If I talk about the melting point key concept, again, when you go down the group, melting point will also increase. Down the group, you can write it increases because the molecular mass increases and it is directly proportional. Now, when I talk about melting point, there is a kind of a different thing over here, that from nitrogen till arsenic, it is increasing, then it will decrease. From nitrogen to arsenic, it will increase. It will increase, then it will decrease. Then it will decrease. So what will be our order? Again, if I ask, it will increase, that means arsenic will have more melting point and then it will decrease. So it will be like this. Antimony, bismuth. So don't get confused between both of them. Don't get confused between both of them. I am repeating and again. Melting point reason is due to the lanthanoid contraction and the inert pair effect. So these are the two major orders that you need to remember. Here we can say it increases, but bismuth will have less than the antimony. But over here it is increasing till arsenic. After that it will decrease due to the lanthanoid contraction and the inert pair effect. I will explain you what is lanthanoid contraction and inert effect in the upcoming segment. So no need to worry about it. Is it clear? So the fifth physical property that we are going to study is about ionization energy. The fifth one is about ionization energy. Now these are lines from NCRT. First of all, understand what is ionization enthalpy, or I would say the ionization energy. It is the energy required to remove electron from an isolated gaseous atom. Ionization enthalpy, or I would say energy. What it is basically? It is the energy. It is the energy required to. It is the energy required to remove an electron. Remove an electron from isolated gaseous atom. To remove an electron from its isolated gaseous atom. The energy required to remove an electron from the outermost shell of the isolated gaseous atom is ionization energy. So this you can tell automatically by your own. I am writing elements: nitrogen, phosphorus, arsenic, antimony and bismuth. See what happens, students. As you move down the group, number of shell increases, yes. Just tell me yes or not. Yes, ma'am. Number of shells increases. What happens? When number of shell increases, the distance from the nucleus to the outermost electron. Now what happens? Shell contains electrons. As number of shells are increasing and we have to remove one electron from the outermost shell, that is ionization energy. The energy supplied to the atom so that the electron which is present in the outermost shell gets removed is ionization energy. So as I'm saying, the number of shell increases. The electron is now far from the nucleus. The attraction between the electron and the nucleus is now weak in comparison to the small atom. What happens in the small atom? The electron is present in this particular shell and the nucleus is over here. There is a force of attraction. But when you are increasing the number of shell, the electron moves at a far distance and the attraction becomes weak. That means in which energy will be given more in order to remove an electron? Obviously the one which is close to the nucleus will be given more energy in order to remove the electron, and the one which is already present at a far distance, a very less amount of energy will be required. Are you getting my point? That means in the case of these, they are small in size. That means over here the electrons are present close to the nucleus, so you have to give more energy. But if I talk about the lower elements over here, as the number of shell increases, we will be supplying a very little energy because already they are at a quite distance and they will easily get removed. That means what is happening over here? The ionization, what is happening over here? The ionization enthalpy or the ionization energy, I would say, it decreases because the lower ones will be provided very less energy. That's why. Is it clear to you? I guess this is now clear to you. Okay, I shall read it over here. Ionization enthalpy decreases down the group due to the gradual increase in atomic size, because the atomic size increases and the distance increases automatically. Because of the extra stable half-filled p orbitals, electronic configuration and smaller size, the ionization enthalpy of group 15 element, now this is comparing with group number 14 also. Now this is the key point, it is comparing with the group number 14. See what it is saying, because of the extra stable half-filled p orbital. Now one more thing, I have to tell you this thing, that group number 15 elements configuration is ns2np3. When you are filling it in, you know, S has one orbital and has 2 electrons. P has 3 orbitals. I have told you just right now. How many electrons are there? 3. So it is 1, 2, 3. They are half-filled. This is half-filled configuration. No, this is half-filled or fully filled. What is half-filled? That one orbital contains 1 electron. This is half-filled configuration. So half-filled configuration and fully filled configuration both are stable in nature. Are you getting my point? So this is what it is saying, that due to the extra stable half-filled p orbital electronic configuration and small size, the ionization enthalpy of group number 15 elements is much greater than the group number 14 elements. Are you getting my point? This is the comparison because they have the half-filled electronic configuration. Okay. Now the next most important thing is the order of successive ionization enthalpies are expected as that. See, now what is this thing? Delta Hi 2, 3, what it is? See, when you are removing one electron from the outermost shell, it is ionization enthalpy of the very first electron. When you are removing one more electron again, it is of the second electron, then is of the third electron. See, when you are initially removing one electron, it will get easily removed. But when you are removing one more electron, now see, when you have removed one electron, what will happen? Initially, the nucleus was holding all the electrons and was providing them the electrostatic force of attraction. Now, if one electron has gone, now its attraction will be more on the other electrons. Now, if you're removing one more electron, it has attracted it in more manner. You have to give it more energy in order to break the bond. Now, when second electron is given out, it will hold other electrons more tightly. That means more energy will be required. So when you are removing the initial electron, the very first electron, a very less amount of energy is required in comparison when you are removing 2 electrons or 3 electrons or 4 electrons. So successive ionization enthalpy trend is this much. Kindly write it down so that we can move on to our next part. Kindly write it down, my dear students, so that we can move on to our next physical property. Now comes the next physical property, that is the 6th physical property, that is the electronegativity. Now, what is electronegativity? First of all, understand this concept. Now, I am explaining you with definitions because these are quite related to the 11th. So, I have explained you. See, I have explained you this also. The thing that you require from 11th standard, I am explaining you, so no need to worry. Now I am talking about electronegativity. What is electronegativity? Electronegativity is tendency to attract shared pair of electron towards itself. What is electronegativity? The tendency to attract shared pair of electron towards itself is electronegativity. I will explain you with the example. First of all, write the definition. Electronegativity. What is electronegativity? The tendency to attract shared pair of electrons towards itself. This is what is electronegativity. I will explain you with a certain example. See, if I have an element A and it is bonded to an element B, let us say that B has more electronegativity. B has more electronegativity than A. What do I refer by this term? I am saying I am having two elements and they are bonded to each other. Okay, and they have two. You are aware that one single bond contains two electrons? Yes, I guess all are aware with this thing, right? I am saying over here that B has more electronegativity in comparison to A. Now, that means B atom has a tendency to attract electron towards itself more in comparison to A. This is what is electronegativity. That means these two electrons are particularly shifted towards B more in comparison to A. That means if I am going to represent it over here, let us say it is A, it is B. That means electrons are slightly towards B. Yes, it is being shared between A and B, but it is more close to B in comparison to A. Are you getting my point? Is it clear to you, right? So what I am saying is B has more electronegativity than A. That means B has electrons shifted towards to it more in comparison to A. Clear? Clear. So this is what is electronegativity. Now when I talk about electronegativity trend in the group number 15, let us see. It is nitrogen, phosphorus, arsenic, antimony and bismuth, right? So you also have to write again and again so that you can learn it out. Now what will be the electronegativity order? What will be the electronegativity order? Let me tell you. When you move down the group, the size increases, right? Why size increases? Because number of shell increases. Yes. Number of shells increases, so size increases. And there is an order that you need to remember, that electronegativity, my dear students, which I represent by En, capital En, it is inversely proportional to size. More the size, less will be the electronegativity. Less the size, more will be the electronegativity. Are you getting my point, what I am saying over here? More the size, less will be electronegativity. Less the size, more will be the electronegativity. It is inversely proportional. So as you move down the group, if size is increasing, then yes, electronegativity is decreasing. Then electronegativity is decreasing over here. Is it clear to you? Is it clear to you? Just read it from NCRT. The electronegativity value in general decreases down the group with increasing atomic size. See, hai na? However, among the heavier elements, the difference is not that much pronounced. They say that when you move down the group, there is a very little decrease, but yes, there is a decrease. Is it clear to you? So kindly write it down so that we can move on to the next physical properties of ours. Kindly write it down, my dear students. Okay, now we shall see the seventh property, that is the metallic character. Now metallic character I have already told you. There is nothing new in metallic character. You have already done this, but still I'll explain you. Let me show you where I have told you the metallic character. I have told you metallic character over here. See, these two are initially the non-metals, then the metalloid, and then the metals comes. So let me explain you over here. If I talk about metallic character, what is a metallic character? What is a metal? I would say it is a tendency to lose electron. If I speak what is metallic character, it is basically a tendency. It is basically a tendency to lose electron. I would say this is what a metal is. Basically, what will happen? So just tell me that if I talk about nitrogen, phosphorus, arsenic, antimony and bismuth, as you move down the group, you know that size increases. Why it increases? Because number of shell increases. Number of shell increases. In which of the following will electron be loosen up easily? Obviously, in which, see, when I talk about nitrogen, the shells are less. The electron is close to the nucleus. When you will increase the shells, the electron will move apart and it will be easily loosen up. That means when you move down the group, the metallic character increases. And due to this, my dear students, due to this only, I have written over here that when metallic character increases, that means initially it was non-metal, and as we move down the group, it developed the characteristics of metal, and bismuth and our MC become what? Metals. So down the group, metallic character increases. That means initially they were non-metal, then it become it holds the characteristics of metals also with non-metals, and after all it become metal. Clear? So this was about metallic character, which I want you all to just write it down over here so that we can move on to our next physical properties. Now comes the next 8th physical property, that is allotropy. If I talk about allotropy, I guess you all are aware with the term allotropic forms. Yes, okay. So what is allotropy? Basically, if I talk about the nitrogen family, that means all the member of nitrogen families, all will form allotropes. But except what? All will show allotrope except nitrogen and bismuth. All will show allotropic forms, allotropes except nitrogen and bismuth. Okay, this is all you need to remember over here. Now comes your next physical property, that is your 9th physical property. If I talk about, that is isotopes. Now what are isotopes? Isotopes are one in which it has same atomic number, but has different mass number. It has same atomic number but has different mass number. Okay, if I give a general example for you to understand, for example, let us talk about hydrogen. Hydrogen exists in protium, hydrogen exists in form of deuterium, and hydrogen exists in form of tritium. So the atomic number for them is 1, but the mass number is 1, 2, 3 respectively, which are changed. Atomic number is same, but the mass number is different. This is what is isotopes. So yes, if I talk about all of these, that nitrogen family, they exist as isotopes. For example, nitrogen, you can consider the atomic number is 7, but mass number is here is 14, here is 15. So atomic number is same, but the mass number becomes different. That is what is isotopes, right? Is it clear to you? So this is the next physical property that you need to remember. Kindly write it down, students. Till then, I'll drink a glass of water. Okay. Now, students, you shall be seeing this thing. The things that we have just studied right now, we shall be reading it from NCRT also. Let us read from NCRT. What does NCRT says? All the elements of this groups are polyatomic except nitrogen. Nitrogen is diatomic in nature. Okay, nitrogen is diatomic, rest are polyatomic. While nitrogen is gas, while all others are solid. This I have already told you, right? Over here, see. See, I have already mentioned. So when you will be reading it from NCRT, it will be more clear to you. See, this is gaseous, rest are solid. Yes? Yes? Now let us see. Metallic character increases down the group. This we have already seen. Nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids, and bismuth is a metal. This I have told you. Yes. This is due to the decrease in ionization and enthalpy and increase in atomic size. Next, the boiling point, they're talking about boiling point, increases from top to bottom in the group, but the melting point increases up to arsenic and then decreases up to bismuth. This also I've told you. Except nitrogen, all the elements show allotropy. This I've told you. Great. And also bismuth is also under this category with nitrogen. Is it clear to you? Yes, students. Shall we proceed further? Now you shall be seeing this data in your NCRT. This is the table that is present in your NCRT. So why I have taken, you don't need to learn this table. There is no need to learn this table. This I have given you so that you can see the trend of the melting point and the boiling point. This I've just shown for you the trend. See, what happened in boiling point? I told you that basically initially it will increase. See, it is increasing. Then what will happen? This is the order. This is the order as you can see for boiling point. Yes. Now for melting point, it will increase up to arsenic, then it will decrease. Is it clear? So this I have taken so that you can see the difference over here. For these two both, I have just shown that you can see the experimental values also of melting point and boiling point from this particular concept. Clear? Now students, comes the anomalous properties of nitrogen. What I am saying is I am talking about anomalous properties of nitrogen. Now when I talk about, as I've told you, all of these elements, if you see, I've told you initially that all these initial elements will have anomalous behavior due to absence of d orbital in small size. So we shall be studying this now. We shall be understanding this in the nitrogen family, why nitrogen show anomalous behavior, why it exhibits anomalous behavior. But before that, one thing more I want you all to write in here, physical properties. One more physical property still left, that is bond strength. Okay, let me tell you, bond strength decreases down the group. Why it decreases down the group? Because number of shells increases, so you will be providing very less energy and the bond will break down. That's why. So bond strength basically decreases down the group. Is it clear to you? This is the thing that you need to mention, one physical property that was left over. Now coming back to the anomalous properties of nitrogen. When I'm talking about nitrogen, nitrogen basically has small size, because we have seen when we move from top to bottom, number of shells increases, number of size increases. That means nitrogen shows anomalous behavior. See, it is gaseous, rest are solid. So why it is showing different behavior? Anomalous behavior. Nitrogen shows anomalous behavior due to small size. Why? Because it has small size. Due to absence of d orbitals. Also, it does not have any d orbital with it, right? These are the major reasons which I have told you. Moreover, it has more, see what if I say ionization energy, it decreases down the group. If I talk about electronegativity, it decreases down the group. That means in a nitrogen family, or in group number, in nitrogen family, or if I talk about group 15 elements, nitrogen has more ionization energy and electronegativity with respect to the other elements in the group. Okay, is it clear to you? Also, it exists is in the form of a diatomic form, that is N2, right? So when nitrogen N2, it exists as N2. If I talk about over here, it basically has like this. This is basically the structure of N2. This is basically over here. How many lone pair of electrons? 2. How many lone pair? 2. How many bond pair? 3. Right? So the bond dissociation energy for nitrogen is also more. Bond breaking energy. Why? Because it is a triple bond, and more energy will be required to break a triple bond. So bond dissociation energy is also very high. Is very high in case of nitrogen. It is near about, in the terms of 941 kilojoule per mole something. So it is about nitrogen. Moreover, one more thing you need to remember. When I talk about nitrogen, it is inert in nature. Nitrogen is inert in nature. What do you refer to as inert? Inert refers to as that it is less reactive. It is less reactive. Inert refers to as it is less reactive. So this was all about nitrogen that we need to understand all about nitrogen. One more thing that you need to know. Nitrogen holds p-pi bond. When nitrogen is forming these pi bonds, it will form p-pi bond. As it does not have d orbitals, so yes, it forms only p-pi bond. But if I talk about the other elements, they do not form strong pi bonds. They will polymerize, but only nitrogen has a capacity to form p-pi bond, not the rest ones. Is it clear to you? So this was all about nitrogen, students. And if I talk more about nitrogen and the other elements, then I would say nitrogen has a capacity to form multiple bonds. But if I talk about phosphorus, arsenic, antimony, bismuth, they will form single bond. And if I talk about bismuth, it will form metallic bond. You can write over here, nitrogen can form multiple bonds. forms multiple bonds. It has a capacity to form multiple bonds. Multiple bonds. But if I talk about the another one, if I talk about phosphorus, arsenic and antimony, they will form single bond. They will form single bond. And if I talk about bismuth, it will form metallic bond. These are the various characteristics that you need to know with regard to, our nitrogen, the anomalous properties of nitrogen. Is it clear? One more thing about nitrogen, if I say, it is about the cationation tendency. Now, if I talk in terms of nitrogen, it has a weak cationation tendency. Why it has a weak cationation? What is cationation? The self-linking tendency. As nitrogen, basically, here, it has weak cationation tendency. What is cationation? It is self-linking. It is self-linking with each other. Okay. So, it has weak cationation tendency of single bond. That means nitrogen, a single bond has a weak cationation tendency with respect to phosphorus single bond. Okay, do remember this. Why? Because when nitrogen will form a single bond with nitrogen itself, the lone pair on the nitrogens will repel each other and the bond will break up. But if I talk about phosphorus cationation tendency, that is the formation of a single bond between phosphorus and phosphorus. Self-linkage is the single bond formation. So in case of nitrogen, the bond will break because the lone pair of electrons on both on the nitrogen will break the bond. It will repel each other. But if I talk about phosphorus single bond, yes, they are bigger in size and hence they will retain. So nitrogen makes a weak cationation tendency with respect to the single bond, while phosphorus doesn't do that. Is it clear to you? I guess now this is clear to all of you. Okay. One more thing about nitrogen, it has a maximum covalency of 4. Nitrogen has a maximum covalency of 4. That means it is maximum of, it will form majorly 4 bonds. Majorly 4 covalent bonds. It is as simple as it is. And why it is? Because there is an absence of vacant d orbital. That's why it has a tendency to form 4 covalent bond. I guess this is clear to you right now. Okay. Now students, comes our next topic, that is about oxidation state. Shall we proceed to the next topic, that is oxidation state? I want you all to write all of these key points first of all. Kindly write all of these key points over here. Now we shall proceed to the chemical properties. That is the oxidation state. Chemical properties and trends starts with the oxidation state. So first of all, let us write all the members: nitrogen, phosphorus, arsenic, antimony and bismuth. Now the questions are generally asked from this concept and it is very most important. First of all, let me tell you, when you move down the group, what is the effect on size? You will say, ma'am, size increases. Yes, okay. But obvious size increases. Why it increases? Ma'am, because number of shells increases. Okay. What is the effect on metallic character? If you remember, metallic character, ma'am, it will increase. Yes. Yes, metallic character will also increase. You are right. This also we have done. Metallic character also increases. That's why bismuth becomes metals and the initial ones were non-metals. Am I right? Is it clear? Right. Now, more question what they can ask you to over here. The oxidation state. What is oxidation state? How will you define oxidation state? Oxidation state basically is a charge on a particular atom. Oxidation state is basically a charge on a particular atom. Now, do remember this basically. The general oxidation state. The general oxidation state, if I talk about, the general oxidation state, if I talk about, is +3, +5 and -3 respectively. These are the general oxidation state. And if they ask you the range of oxidation state, the range lies between -3 to +5. The range lies between -3 to +5 with respect to nitrogen. And if I talk about the general oxidation state of the group number 15 elements, so it is +3, +5 and -3. Is it clear to you? Now, the tendency to show -3 oxidation state will decrease as you move down the group. Tendency to show -3 oxidation state will decrease down the group. But if I talk about the stability of +5, it will also decrease the stability of +5. But the stability of +3 will increase down the group. I will explain you what I am saying. See, just leave this -3 oxidation 3 concept over here. Just understand first of all by +5 and +3. See, when I talk about nitrogen, it exists in +5 oxidation state also, and it exists in +3 oxidation state also. Similarly, no, I will tell you what I'm going to say. You will get to know. Okay. First, understand that all of these elements can exhibit two kinds of oxidation state. That means they can exhibit two kinds of charges on them. That is +5 and +3 respectively. So what happens when I'm saying that, if I'm saying it will have +5, +5, +5, +5, +5 oxidation state. And if I say that it will have +3, +3, +3, +3, +3 oxidation state, which will be more stable. See, if I talk about bismuth, bismuth +5 and bismuth +3, which is more stable? So bismuth +3 oxidation state will be more stable. Why? Because as you move down the group, the stability of +3 oxidation state will increase. The lower ones will be more stable in +3 oxidation state, while the higher ones will be more stable in +5 oxidation state, because the stability of +5 decreases. So initial ones are more stable in +5 oxidation state, while the lower ones are more stable in +3. The reason for this is inert pair effect. The reason for this is basically inert pair effect. First of all, write it down so that I can explain you what is inert pair effect. First of all, write it down so that I'll tell you what is inert pair effect. Kindly write it down so that I can explain what is inert pair effect. Okay, shall we write? See, what is inert pair effect? Inert pair effect basically is the reluctance. It is the reluctance of two ns electrons. It is the reluctance of two ns electrons. That means it is not allowing the two ns electrons of the outermost shell. Of the outermost shell to what? To participate in bonding. I will explain you. See how? Basically what happens is, as you can see over here, okay, let me write over here. See, you know this thing that if I write nitrogen, phosphorus, arsenic, antimony and bismuth, I know it is N is equals to 2 over here. So it is 2s2, 2p3. It is 3s2, 3p3. It is 4s2, 4p3. It is 5s2, 5p3. It is 6s2, 6p3. So what happens? Initially, when you talk about over here, initially, here all of these 5 electrons can participate in bonding. So it can show +5 oxidation state. Here also it can participate. Here also it can participate. But when you move down the group, the inner electrons, this s electrons won't participate in bonding. They won't participate. Hence, only 3 electrons will be participating in the bonding. So +3 will be more stable. This is what is inert pair effect. That initially all of these electrons are participating, but when you move down the group, the 6s2 electrons move inside and it is more attracted towards the nucleus in comparison to the 6p3. So these s electrons won't participate in the bonding, and only these p orbitals will be responsible for the participation, and hence will cause an oxidation number of +3. And here, so +3 oxidation state is more stable in comparison to the our +5 oxidation state. Yes. So students, rest of the chemical properties and the next segment we shall be covering in the next lecture. First of all, write it down. Okay, now the chemical properties, that is reactivity towards hydrogen, reactivity towards oxygen, this we shall be covering in the next lecture. I hope so, as this was our first lecture, so we shall end over here. Now these are some homework questions that you have to write in the comment section. So these are your homework questions. This is your very first homework question for today. Okay, nitrogen shows different oxidation states ranging from, you have to comment your name and the answer in the comment section. And yes, I look up to all the comments in the comment section, so you have to write. Okay, so we shall be discussing the homework questions in the next lecture. Don't worry about it. Homework questions will be discussed in the next lecture. Now comes the next one. That is question number 2 as a homework. See, I am not saying that I said that most of the students will be able to do so and most will not be able to do so. So if you are able to do so, it's a proud moment. If you are not, you will learn something. Okay, so this is question number 2, which is as your homework. Okay. Okay, rest is related to our, okay. Okay, the question number 3 for your homework is, Which of the following has highest boiling point? You have been given. So 3 questions I have given you right now as a homework, which you have to write in the comment section. Right now, I have given you number first as your homework is to solve question given in class, in lecture. The second one is to solve your practice sheet. Yes, the question with regard to reactivity towards hydrogen or reactivity towards oxygen, just skip that questions because we shall be covering in the next lecture. So the topics which we have covered in today's lecture, you can solve that questions from your in your practice sheet. Third is you have to read the NCRT. Yes, we have already read the NCRT topics, but again you have to read the NCRT by your own so that you can understand it in depth. And the foremost thing that I've already told you is to revise, because revision is really very important. So kindly write it down, students. Okay, so yes, we shall end our today's session over here. So before ending, I would say some few lines for you all. Opportunity knocks many times every day. Opportunity knocks many times every day, and if carelessly slighted, departs on its way. But it never evades you for some time again. It is sure to return, and if seized, it will remain. So never miss any opportunity in your life, okay? And students, be motivated, okay? Just don't lose your confidence that exams are approaching. If you want to succeed in your life, you should have patience, you should have consistency, and you should do hard work. Right? This is all what matters. So we shall be meeting in the next lecture. So till then, keep smiling, keep learning. Thank you so much and have a good day.